this is, as I've said already, and this is an MATD 5054 class, and it is designed to strengthen what you do the face-to-face class, because the face-to-face class you are supposed to have at least, I think, you are supposed to have 6 hours, but because of what you all know, this virus, it's a problem now. So we are blending both the face-to-face and online. So we are going to this thing. Look at Unit 1. We are going to look at Unit 1 today. So without wasting much time, I'm going to load the activity, this thing for Unit 1. Please, have you all got your hard copy of the book, of the learning material or the study guide?
Yes, sir.
No.
That's the question. No.
Yes, sir.
Yes,
No.
sir.
All of you have only got the soft copy. You only use the soft, but you have the soft copy. Let me see, a minute. A minute, please. I want to load this basic operation. Okay. Okay. This I'm trying to load our the material, so it is still loading. I will just get it on the screen very soon. And before we go on, please, if you cannot see properly, you yourself can be able to what do you call it? Enlarge your screen. You see where there is pencil, where the mouse is. Down here, you will see a sign. It's like it's like a zoom sign. You click on it, then you just click on the plus to zoom if you can't see it properly. Now, most of please, before you go to Xerox, please tomorrow I'll go and find out tomorrow whether books are in. So if it is in, I'll announce it to you. Then you can go for it. But I would like to find out first before you can go to Xerox. Is that fine?
Sir.
Okay. Maduna, okay, I understand. And also the session will be recorded. So at any point in time, you can join. You can also view it. I will send you the recording here. So let me see whether our okay, it has finished loading. Let me just put it on the screen. Then we can see what is happening. Okay. Okay. I believe those who have already attended class, you have the face-to-face class. You have seen something like this. You have been able to do these activities. Activity 1.1. I don't think it's for sale. I don't remember they selling it. If it's available, you can just go for it. Okay, good. Now, we are going to look at the activities in the book, but I just want to find a very plausible place to start. Minutes. Okay. Now, the first thing that I would like to touch on is scientific notation. What do you mean by a scientific notation? You can explain to me what we mean by a scientific notation. Because there are some of these things, most of you may think you know them, but can ask who have been there before. Now, when it comes to exams, it becomes a problem. It becomes a big problem. So we will take time to go through these things little by little. So the first thing is who can tell me the meaning of a scientific notation? Who can tell me the meaning of a scientific notation? When we say a scientific notation, what do we mean? Those who have attended the lesson, I think you were told. When we say a scientific notation, or if I give you a number like this, if I give you a number like this, let's say 50, 100. If I give you a number like 500, 500, and I 505, and I ask you to write it in scientific notation, how are you going to write it? You can tell us how he or she is going to write it. If I give you a number 505, then I ask you to write it and write the number for me, how are you going to write it? You can help us. Like I've given you a number 505. Yes. Um. Oh, sorry. Tell me so. Can you hear me? Can you hear me? Can you hear me? Yeah. Hello. Hello. Ask a question.
Yes,
Five.
if you want 505 or 505, it's going to be 505 times 10 to the power 2, sir, written in scientific notation.
It's going to be
5,05 times 10 to the power 2 if you use two decimal
times 10
places
times 10
to the power 2.
power 2. Okay, good.
Yes, sir.
So if you have been able to do this, can you tell me what a scientific notation is? Can you describe this for me? What is a scientific notation? When we say a scientific notation, what do we hear? Can you hear me? Please, can you increase the volume because for my I can see clearly here that this, the microphone is fine here. The sound is going through. So can you check your side and increase the volume of the device you are using, please? Just increase the volume of the side the device you are using. Okay, good. So can you now explain to me what is a scientific notation? Yes, Tumelo.
Excuse me, sir.
I said, can you explain to me what is a scientific notation? When we say a scientific notation, what do we mean by a scientific notation? Yes, Tumelo. Please, you don't, yeah, Yvonne. Can you explain to me what the scientific notation is? Oh,
Sir,
Yvonne, is your hand up?
can you hear me?
Yes, we can
Yes,
hear
my
you,
hand
Yvonne.
is
Clearly.
up. Can you hear?
Yes, please, we can hear you.
There's a note that I made. I wrote a scientific notation is a whole number between 1 and 10 that is powered by 10. I
Very
don't know if
good.
it's correct.
Please,
But
it's extremely important. Very good. A scientific notation.
How?
The number, the first number you see there, it must always be between 0 and 10 times, and it must be written as an exponent of 10. 1. The first number here must always be between 0 and 10. No, 1 and 10. Then the number in front here must always be an exponent. For instance, if I give you 5 and I say, write for me 5 in scientific notation, it's going to be 5, 0, which is between 1 and 10 times 10 to the power 0. Because 10 raised to the power 0 is 1. Yes, Yvonne. Your hand is up again. There's a mistake. Okay. And please, one will ask.
yeah, so my
Yeah,
carry on.
yeah, Yvonne, we are listening to you. Yvonne, we are listening
It
to
was a
you.
mistake, sir. You can carry on.
Okay, thank you.
Sir, it was
Now,
a mistake. You can.
okay, sure. Please, you have to one will ask. Yeah, Tumelo, your hand is up.
Yes, sir. Apologies for not answering, sir. My phone crashed when you asked the
But
definition
is
of
it
a
fine now?
scientific notation. Yes, it's fine now, sir.
Yes.
All right. Thank you very much, sir.
Okay, sure. Now, scientific notation is a number, as Yvonne have said correctly. We always write it as a number between 1 and 10 as an exponent of 10. Then one will ask, then why the need for a scientific notation? We call it SI. I believe you have seen it before. We call it SI. One will ask, why the need for a scientific notation? It's important because in science, numbers are very huge. So at times, maybe if you are writing, let's say, I believe most of you have done physical sciences before. Maybe the radius of the Earth, or those of you who have done physical sciences before, the constants. If you can go and check it, the back of your physical science paper, you realize that all the constants there have been written in scientific notations. Why have they been written in scientific notations? It has been done numbers. That, or it will be easier for you to write the numbers because the numbers are so huge. For instance, if I ask you to write Avogadro's constant, it's 6, 0, 2, 3 times 10 to the power 23 times 10 to the power 23, which is in scientific notation. So you can imagine if I ask you to write the whole number, when it's not scientific, you can imagine how big the number is. That is the need why we write numbers in scientific notations. That is why it's the first thing that you must know if you want to pursue science to the highest level. It is one of the first things that you must acquaint yourself with what we call a scientific notation and why there is a scientific notation. So here you realize that if you read the definition or the reading for a scientific notation, it says that a scientific frequency have to deal with large numbers and very small numbers. For example, Alpha Centauri is about, this one is 40 trillion, very huge number from the Earth. It is inconvenient to write numbers like this because they are hard to visualize. Okay, Maponya, you are asking a question.
I wanted to ask, say,
Yes.
you said, say for instance, write 505 in scientific notation. It's going to be 5,05 times 10 to the power of 2, right?
Yes, please.
So does it matter if I write 0,505 times 10 to the power of 3 instead?
0. Say the second one again.
0,505 times 10 to the power of 3.
Good. Maponya, if you remember, if you watch, I don't know whether you were listening from the beginning, but at the beginning, Yvonne defined for us a scientific notation. This number is not a scientific notation. Why is it not a scientific notation? Because the number in front here is not between 1 and 10. Can you see that?
Oh, I thought you said from 0 going up.
Oh,
Okay.
sorry. It might be between 1 and 10.
Okay.
I hope it's clear. Please, any questions again? Please, any questions again?
No, I am cool, sir. Thank you.
Okay. Stepping so, are you clear?
Yes,
Are you
sir. I'm
clear?
okay. Yes, sir.
Okay, good. Okay, good. So we can go on. So, please, that is the first thing I want you to do. Yes, Olive. Olive. Okay, good. Now, so if you can look at these numbers, so here you can have a scientific notation in a normal form. This number is in scientific notation. When you come here, it's in the normal form. So that's the difference between a scientific notation, a number, and a normal form. Now, if you can look at here, the number is in a scientific notation. When you come here, then you write it in a normal form. If you look at here, this number is in a scientific notation. But when you come here, it comes to a normal form. And in the same way, when you look at this number, it is in a scientific notation. But when you look at it here, it comes to a normal form. Can we see that? So that's the difference between a scientific notation and a normal number. They are the same thing, but it can be written in two different ways. They are the same thing, but it can be written in two different ways. Please, any questions? Please, any questions? Okay, good. So if there are no questions, let's go on. So now the first question says that write each of the numbers in normal form. So here you find out that the comma is here. So if it is times 10 to the power 15, yes, one delay. One delay, your hand is
Yes,
up.
sir.
Yes, your hand is up.
Yes, sir. Can you please explain when we look with normal numbers and then we go back to a notation?
I can't get your question clearly. Let me say it again.
Sir, can you
One delay, can you write it? If your voice
in
cannot, can you type it?
we have 0,
Yeah,
0.
yeah.
Yes, sir.
Can you come again? I can't hear you clearly. You said you have 0,0. One delay,
We have
can you just
0,
type it?
0.
0,0.
We have
Come
0,
again.
0,
0,0.
0, 42. 042. 042. Sir,
0,042. Okay, I can hear you. So what's the question now?
yes, sir. Then maybe the question says write it in a scientific notation. What we must look at.
0,042. So now the number is in normal form. Have you seen that? Now,
Yes,
scientific
yes.
notation
Then
says that. Yes.
then the
Scientific.
question says
Okay, ask a question. Yeah.
the question says we must write it in a scientific notation.
Yeah.
What we must look at.
So now, you see that the comma is here. Scientific notation says that the first number must be between 1 and 10. So that means that this comma, you move it 1, 2. It will be 4, comma 2. Have you seen that? But you cannot distort the number. So 4, comma 2 will be times 10 to the power negative 2. Have you seen that? That this number and this number is the same. You see that? But in scientific notation, it says that the number must be between the number in front, that is this number, must, or the base, or this number must be between 1 and 10. Make
1
sense? And 10.
1 and 10.
Yeah.
Sir.
Yes, between 1 and 10.
Oh, okay, sir. Okay, sir, you can carry on.
Okay. Can carry on. Any questions again? Yes.
You can carry on, sir.
You can carry on. Okay, good.
Yes.
So in this chapter or in your exams, you can be asked to write numbers in either scientific notation or in normal form. So now if you can look at this number, it is in scientific notation. Have you seen? So we have 6,022. So it is times 10 to the power 15. So it is the number on top, the 10 is positive. That means that you're going to move to the right. So this comma will move, so it is here. It will move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This side. Please, my mic here, those of you say you cannot hear me. My mic here is right. So maybe check because it's easily indicate that the volume, the noise is, or my voice is coming through. So may you please check the volume of your device and increase the volume and let's see. Yes, Dube. Your hand is up.
Good evening, sir.
Good evening.
Sir, I've got a question here.
Yes.
If the question says 15,952, write it in a scientific notation. What should I do there, sir?
Okay,
15,952.
952. 952. And you
Yes,
see
sir.
that in science, we use rules.
Okay, what? Okay. I'm all ears, sir.
I don't know, maybe you were not here at the beginning. When I started, the first thing we did was we defined what a scientific notation is. Have you seen? Then Yvonne gave a very correct definition of scientific notation, that the number, the base or the number in front or the base number must always be between 1 and what? 1, I'm coming, 1 and 10. So that means that this arrow must move one step like this. You see that? So it's going to be 1, 5, 9, 5, 2 times 10 to the, because you moved once, it will be times 10 to the exponent 1, and it will be in scientific notation. So that the key thing is that this number must always be between 1 and 10. Then whatever you do the adjustments here, so that this number and this number will be the same. Does it make sense to you?
Hey, I'm very lost,
Does it make
sir.
sense to you?
I'm very lost,
Then,
sir.
okay, can you tell us where you are lost? Or tell us exactly.
Where you said 10 to the power 1, sir.
Yeah.
I'm very lost today.
Because you see, when you are moving to scientific notation, look, you see that it was the number you gave me was 15. Yes, Luando, I'm coming. 15,952. Obviously, this is the number you gave me, right? Now, change to scientific notation. Now, this number here must be between 1 and 10, but as it stands now, it's not between 1 and 10. Do you agree to that?
Yes, sir.
Good. So for it to be between 1 and 10, I move the comma 1 decimal place to the left. Have you seen that? Then it becomes 1, 5, 9, 5, 2. Because I moved it 1, it means that means that I am raising it to the 10 to the power 1. Understand me? Because I moved it once.
Okay. No, I see now.
Yeah. Exactly.
Understood, sir.
Okay, good. Please, any question again? Tuko, any question again? Somebody also raised his hand. Any questions again, please? Because I saw others raising their hands. Yes, Luando, your hand is up. Luando, your hand is up. Luando, your hand is up. Okay. So please, you see that here it is 1,673. The comma is here. So it's times 10 to the power negative 17. that the comma must move 17 times if you are writing it in the normal form. The comma must move 17 times. So the comma is here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Have you seen that? When it is negative, it moves to the left. When it's positive, it moves to the right. And when you are changing from normal form to scientific notation, when it's to the right, it's negative. And when it's to the left, it's positive. I hope you understand that jargon. Okay, good. Maybe as we go on, you're going to understand better. So now we say that for instance, this number, if you are supposed to write it in scientific notation, see, it will be cumbersome to write such a big number. Have you seen? That is why actually scientific notations exist. That is why scientific notations actually exist. So you find out that this number, we start from here. We go write in scientific notation. The number must be between 1 and 10. So you must find a way to change this number. You must find a way to change this number to so that it will be between 1 and 10. Yes, Luando, your hand is up.
Oh, okay, so yeah, my mic is there. Can you hear me?
Yes, we can hear you.
Okay, so if you see the previous example you made, the one with the 602 times 10 to the power 15.
One with the
one with the 6,022.
that's the previous page. Let me see. Hey, that one.
So,
You are talking about the ones we did previously.
the one
Okay,
with the
this one,
plus
yeah.
sign.
Yes, I've seen it. It's this one.
So what if they gave us the normal number, but then all those zeros, they maybe were numbers like 3 and 4s and 5s.
Is that what? Can you come again? Can you repeat what you said again?
What if
Can you repeat what you said
they
again?
gave us the normal?
Yes.
What if they gave us the normal number, but instead of the zeros, there were number there, maybe 2s and 4s.
Please, you are breaking. Can you put your mic on your mouth very well? And we can't hear you properly.
Okay, so I'm asking if maybe we were given the normal number.
Yes.
Then they say we should write it in scientific notation.
Yes, it's the same way.
Instead of zero.
Okay.
Yeah, they say they didn't have zeros, it had numbers there.
The number doesn't do what?
Instead of the zeros, you see the many zeros instead of 2 zeros, if it had numbers.
If you are using this thing, because you are not, if you are using a headphone, can you just, if you are using a phone and a headphone, can you just remove the headphone and just repeat what you are saying? Because we can't hear you at all.
Okay, sir. Ask again.
Yeah. Yeah.
See the example. What if they gave us the normal number, but instead they had another number like 2s and 3s and 4s?
Okay, no. Let us let me see whether I can understand what you are saying. Okay, look. This is a normal number. This is a normal number. So what the question you are asking?
So instead of the zeros, like I'm still trying to figure out something. Instead of the zero, the many zeros.
Yes.
Put numbers there instead of zeros. What happened?
Yes, you write for instance, you are talking about maybe you have let me see 6, 0,
0,
2,
2,
3,
2,
4,
4,
7,
5.
6,
Yes, like that.
7. Normally, big numbers, it cannot continue like that. Tell me, it will end
Oh,
somewhere, but you must write all the numbers. Tell me,
okay.
so it will be 6, 0, 2, 3, 4, 7. If you don't write all the numbers, you distort the numbers. Have you seen that? But normally,
Yes, sir.
big numbers in somewhere. Have you seen that? So here we go 1, 2, 3, 4, 5, 6, 7. So to be times, yes, Luando, times 10 to the
Yes,
power
sir.
7. Am I explaining myself to you? Luando, are you fine?
Yes, sir, I'm fine. Thank you.
Okay, good. Yeah. Aduna, you also have a question.
Yes, sir, I do have a question. So a number
Yes.
like pi, can you write it in scientific notation? Because we're told that after the comma, the numbers go on forever. For pi, that is.
Pi is an irrational number. Hope you know an irrational number.
Oh, so we cannot write irrational numbers in
Yeah,
scientific
irrational
notation.
numbers don't end. Yeah.
Okay, got it.
Irrational numbers, it's already in scientific notation. Doesn't mean they don't end. Doesn't mean
Okay, got it, sir, got it.
square root of numbers and those things. You have seen.
Oh, you can, okay, got it. You can write it as
Yeah.
the inverse or square root of.
Yeah. Because irrational numbers don't end. I get your point.
Okay, yeah,
Okay, good.
got it. Thank you,
Yeah.
sir.
Welcome. Now, any questions again? Any questions again? Yes, Sister your hand is up.
Can you hear me, sir?
Yes, we can hear you loud and clear.
Okay, sir. My question is, you said a scientific notation is a whole number between 1 and 10. And then I see...
Multiply by,
yes, multiply.
not by an exponent of 10.
Yes, you multiply by a power of 10, right?
Yes.
So I see a 0 there after the comma, 6,0, or the number that has to be between 1 and 10 is the number before the comma.
A number before the 10.
A number before a 10.
Like 6,023 is between 1 and 10. Let's say that 1,673 is between 1 and 10. 3 is between 1 and 10. 4,2 is between 1 and 10. 3,8 is between 1 and 10. 7 is between 1 and 10.
Oh, okay, sir. Okay, sir. I can see that. Thank you.
Okay, good. Any questions again? Sister Biso, your hand is up again.
No, sir. I'm okay. You can call. Okay, you can carry on.
Okay, yeah. Wazi, your hand is up. Wazi, your hand is up.
So I just have a question. For activity 1.8, when I had marked my work, I had seen that you had written 1,0 times 10 to the power of 6 for
Let's see,
exercise
activity 1,8. Let's see. Question.
For 2.1. So now I want to know that is there any difference if I write 1 times 10 to the power of 6 where you have written 1,0 times 10 to the power of 6? Is there a
Yeah,
difference
it
with
doesn't matter. The most important thing is that the number in front, you must not distort the number. Have you seen that? For instance, 6, 6, 0 is the same as 6. Have you seen that? But so let us say if I have 60, I think I get your question. Let me explain it to you. So let us say if I have 61, let us say if I have number 60. Have you seen that? I say write 60 in scientific notation. Somebody will say 6 times 10 to the power 1. Somebody will say 6, 0 times 10 to the power 1. All of them is legal because they are all between 1 and 10. They are all between 1 and 10 because you have not distorted the number. The number is still there. You understand me? Because the aim of a scientific notation is to be able to write the number in a very simple form. Understand me? So here, in both cases, you have not distorted the number is the same. But let us look at this. Let's say I have 61. Then one person will write 6, 1 times 10 to the power 1. Another person will write this 6 times 10 to the power 1. And this person will say that no, I approximated, but this one will be wrong because now you have distorted the number. Understand me?
Okay. Yeah,
So
no,
if
I
I
understand.
multiply this one, I don't get 61. You get my point?
Yeah.
Okay, good.
No, I understand. Another question is that I see you say 10 to the power of 1. Do you have to say to the power of 1, especially when you have written it like that, or can you just say
Yeah,
could
10
you just
exponent 1 is the same as 10, so I think it's the same. There
sorry?
will be no problem. I said 10 to the power of 1 and 10 is the same thing, so there will be no
Okay.
problem.
Okay,
And let
cool.
us say if I write this number 6, and I say write 6 in scientific notation, as you know that it will be 6 times 10 to the power 0, because you know that any number raised to the power 0 is 1. Have you seen that?
Yes.
It will be
Yes.
6 times 10 to the power 0. Does it make sense?
All right. No, thank you so much.
Okay, good. You are welcome. Yes, any questions again? Any questions again? Yes. Any questions again? Any questions again?
Please go on.
Okay, we can go on. Okay, good. So
Yes, please.
please, that is the key thing about scientific notation. So in science, if you simply follow the rules, you are going to be there. Yes, one delay, your hand is up again. One delay, your hand is up again.
Yes, if I'm given 0,035 and I am asked to change that number to scientific notation, must I include a step which says 3,5 over 1000? Will I be penalized if I don't?
0,035.
Yes.
You see, in mathematics, we don't really have one method exactly. So once the answer is correct and I check and you use the legal process, there's no way I can back you wrong because you cannot have only one way of doing it. Because the simplest way of doing it is that here is the comma. Understand me? The comma will move. The comma here is moving 1, 2, 3. Have you seen that? Which will be 3, 1. But because the comma is to your left, it will be times 10 to the power -3. So in the same way, if I have, let's say, 35,000 like this, once it's 35,000 like this, the comma is here. So we are going to go 1, 2, 3, 4. The comma will come here. So we have 3,4. Because now the original comma is to your right, it will be times 10 to the power 4. Of course, the comma moved 4 times before I was able to convert the number between 1 and 10. Is it making sense?
So my question is, must I
Yes.
include the step which says 3,5 over 1,000?
You can use any step that you are comfortable with. The most important thing in this issue is that your answer is correct.
So I can straight away get to
Yes,
write the answer.
exactly. The most
Okay,
important
sir.
thing is that your answer is correct. Understand me?
Okay, sir. Thank
Uh-huh.
you, sir.
Because this is it's legal because somebody can see it straight away and see the answer. So you can't penalize such a person. Understand me?
All right. Okay, sir.
Yeah. Okay. So please, that is scientific notation for you. That is scientific notation for you. So here you see that diameter of human hair is 0,0007, which is a very small number. So in scientific notation, here you go 1, 2, 3, 4, 5. The original comma is to your left, so it will be 7.5 times 10 to the power negative 5, as you see. Here it's a huge number. It says the diameter, the distance from Pluto to the Sun, which is a very huge number. So the reasons why we are using scientific notations is that in science, numbers are huge. So in order for the numbers to be made simple for everybody, that's why we are using scientific notations. So here, the comma is here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be 5,95 times 10 to the power positive 9 because the original comma is to your right. The original comma is to your right. I hope it's making sense. I hope it's making sense. Now, the next one says that write the following in normal form. So in normal form, you just change. So let us say this one you have it's already in scientific notation. 1,5 is already in scientific notation. So write it in normal form. So here is 1,5. The comma will move 1, 2, 3, 4, 5, 6, 7, 8. Whenever the comma moves, there will be a 0. 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 And there will be a 0. So you are going to have 0 is 1, 2, 3, 4, 5, 6, 7. A minute. Oh no, we made a mistake. Sorry. We have 1, 1,5. So the first one came here. So there will be no 0 because there was 5 there. So 1, 2, 3, 4, 5, 6, 6. I'm coming. 6, 7, 8. So there will be a 0 here, 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 a 0 here. So it's going to be 1, 5, 0, 0, 0. 0, 0. We have 7, 0. It is there. Yes, it seems that your hand is up. It seems that your hand is up. Please don't forget the units.
Sorry, it's a
Because at
mistake.
times, the multiple choice they can. Okay, thank you. Multiple choice they can bring. At times they can write this. They will bring the units. They can write another answer without the units. You must know that the original number they gave you had got units. Because I hope you know that in physical sciences that when you don't write when it's a quantity and you don't write a unit of the number, it's a problem. Now, the next one is say that the mass of a house. So we have 1, 5. Now it is negative. So negative, that means you're going to move to left. So the first one will come here, first 0, second 0. So it will be 0, the comma is here, 0. So it will be 0, yes. Yes, one delay, your hand is up. Yes, please.
Sir, sir,
Yes, I'm listening.
sir,
Yes, I'm
can
listening.
you please try to write can you please try to write in the matrix because I can't see anything. I
Oh,
just see
can you
1
see
0.
from here? Can you see from here?
Sir? Yes,
Can you see
I
from
can't see
where I'm?
anything.
Okay, wait. Let us see where you
Sir?
can see. Can you see from where I've drawn a circle? Can you see from here?
Yes. Yes.
Okay, I understand you. Okay, sure. Now, the next one says that write the following in scientific notation. The first one says that Bloemfontein is 1 million meters from Cape Town. So 1 million is like this. We have 1 million. It's going to be like this. 1 minute. 1, 1, 2, 3, 4, 5, 6. So the comma is here. So we go 1, 2, 3, 4, 5, 6. Original comma is to the right, so it will be 1, 0. Sorry, it will be 1, 0, 0 times 10 to the power 6. Or somebody can just write 1 times 10 to the power 6. Another person can write 1 times 10 to the power 6. Okay, good. Now, the next one says that the sun has a diameter of 1 billion meters. So the same way, we are going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. The original comma is to the right, so it's going to be 1 times 10 to the power 9. Yes, Sakile, your hand is up. Sakile, your hand is up. Sakile, your hand is up. We are listening to you. Sakile, your hand is up. We are listening to you. Okay, good. So the next one, a thickness of paper is 0,0001. So in that case, we are going to go 1, 2, 3. Yes, Luazi, your hand is up.
So I just have a question with activity 1.9, the last one.
Okay, we are going to get there. So when we get there, you ask the question. Okay. Good. So we have 0,001 meters. So it's going to be one, it's going 1, 2, 3, 4. It will be 1,0 times 10 to the power 1 times 10. Sorry, we went 1, 2, 1, 2, 3, 4. So times 10 to the power negative 4, because the original comma is to the left. Next one says that write the number of seconds in 1 day in scientific notations. Now there is 60 seconds in a minute, then there is 60 minutes in an hour, then there is 24 hours in a day. Let me write here. Sorry, somebody said you can't see. 60 minutes, 60 seconds in a minute times 60 minutes in an hour. That means that there is 3,600 seconds in an hour. And there is 24 hours in a day. So we are going to have 60 times 60 times 24. We are going to have 60 times 60 times 24, which is going to give us, let me use my calculator here. A minute, please. A minute. Why is this not working now? Okay.
So
It's
the
coming.
answer is 86,400.
It's how much? Can you come again?
86,400. 86,400.
86,000. Good. 400. So this one is in a normal form. So in scientific notation, that means that you have 86,400 seconds in a day. So in a normal, this is in the normal form. So 1, 2, 3, 4, which will be 8,6,4 times 10 to the power 4. And you write the number in scientific notations. So please, any questions on activity 1,8? Any questions on activity 1,8?
No, sir.
Okay, good. So now let's go to activity 1,9. It says that, and the first one says that the distance in kilometers from Earth to Mars is approximately 230 million. Write this in scientific notations. The comma is here, so we go 1, 2, 3, 4, 5, 6, 7, 8. So to be 2,3 times 10 to the power 8. Then we write it in scientific notation. Then our next one says that light moves 30. Yes, Maduna, your hand is up.
So I wanted to ask, so there's rules against the number which is multiplied by 10, and we also have a rule that you always use a base of 10. Is there a particular rule for the exponents, or can it be any number? Can it be 10 to the power of 1,000 or 10 to the power of 2,000?
Yes, depending on how many times you move the decimal place.
Oh, so it's possible to have 10 to the power of maybe 2,000.
Yes, but normally in a normal examination, you can never be asked to convert a number to scientific notation where the power is 2000. Understand me?
Okay.
The simple thing that they want you to understand is that I is a number written in scientific notation. And how do you see when a number is written in scientific notation?
Yes, yes.
Okay.
You get the point. But it will be highly unrealistic to ask you to write a number on your calculator. The calculators you use, this FX82. If you punch any huge number, it quickly converts it to scientific notation for you if you have noticed this.
Yeah, it always turns it to scientific notation.
Good.
If it's
So they
it's
simply
really
want you
big
to
number.
understand why one the objective is for you to understand why we convert numbers to scientific notation. And you must know it when you see that a number is in scientific notation. Hope it's clear. Okay, good. Yeah. Now, for next one, we have 0,000000001s. So it says that light moves 30 centimeters through the air at 0,00001 second. Find the speed. Find the speed. So it says that write your answer in normal form and in scientific notation. Now you all know from your physical sciences that speed is distance over time. So here we are having the distance is 30 centimeters. Here it says the units must be centimeters a second. So that means that we don't need to do any conversion here. It will be 30 divided by 0. And if you can notice, this number, it will not be easy for you to write it normally. So you can easily convert it to scientific notation. It goes 1, 2, 3, 4, 5, 6, 7, 8. So you can just say 1 times 10, 1 times 10 to the power negative 8. Then you can write the answer in normal form. Then later you convert it to scientific notation. Let me see. There are some questions here. He said, oh, okay. Oh, look, can you see me? Can you see the box? Oh, look, can you see the box?
No, sir, I cannot see.
Can you see the box here? Can you see the
I
box?
can see only part of the box, sir.
Yeah, can you see the
Sir,
box here? Can you see the box here?
I can only see part of it, the upper part.
Okay, wait. Maybe you cannot see clearly. Let me just
Yes.
use a minute. Let me just use this. Let me see. Can you see? Okay, let me just do this. Can you see my writing here? I'm writing zigzag. Can you see the zigzag?
I do not see any writing.
What about here? Then what about here?
Still, sir, I do not see anything.
Yeah,
Yeah, I can see now, sir.
you can see here.
Yes, I can see now.
Okay, good. Now, so please, that is it. You can just divide this thing is 30 is 30 divided by 1 times 10 to the power negative 8. Then you can easily Then yes, then you can easily write it in scientific notation in a normal form. Yes, somebody asking a question. Hope all of you can see now. Any questions, please? If you are not talking, it's better you put off your mic, please. You only talk if you only open your mic if you want to say something. It's not follow.
So are we always going to be given this formula, like the speed distance over is equal to distance over time?
Yeah, but yes, but most of the time you are going to give you the formula because the idea here is for you to be able to know how to write this in scientific notation. That's what I mean.
Okay, so
Yeah. Now the next one says that yes, not all your hand is up again. Your hand is up again. Yvonne, yeah, Yvonne, hand is up.
Sir, can you hear me?
Yes, we can hear you.
Can you please confirm your scientific notation for the time?
Yes, you see the comma was here. Okay. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, sorry, it's times 10 to the power negative. Thank you very much. It's times 10 to the power negative. Thank you, Yvonne. Yeah. I hope it's clear. Okay, good. So we can go on. The next one says that a snail moves at about 10 meters. In Yvonne, your hand is up again.
Mistake, you can carry on, sir.
Okay. Snail moves at about 10 meters in 1,000 seconds. Find the speed in meters a second. So is the speed is going to be is distance over time. You've seen that. So the speed is in meters. Yes, tell me. So your hand is up.
My question is, do units matter? Like, will you punish me if I didn't write units in my final answer? So like
Yes.
meters per second.
Good. You see, when it's a written test, I can overlook it. But you see, when it's an objective test, everything, maybe at times they can write two answers, but they can write two. The other one they can write 2 meters. Everything. Then people will complain that I wrote 2. I was marked wrong, forgetting that this is the correct one. This is an objective test because remember that objective tests have got um, rigid answers. But units are very important, but it can easily be overlooked when it is a written test because you're not doing a science here, you're doing mathematics. So the most important thing is for you to be able to write numbers in certification. You know that when it is science, the units must be there, of course. Yes, Mbuelo.
Sir, are we all
Mbuelo,
attending the online class tomorrow? Are all groups attending the class, not the online, the face-to-face class?
No, not all groups. It is only some of you missed today, and those of you who have already attended, there's no need for you to attend tomorrow. Everything. It is only those who missed today because you're supposed to come off. You're supposed to attend tomorrow. But I've said that for now, we're not using the groups anymore. You simply have to look at it. Then
Good network, yeah.
please put off your mic if you are not talking. So please, you simply look at a day that will suit you, and you simply attend on those days. You simply look at a day that will suit you, then 10 as simple as that. Now, next one says this, that a snail moves at about 10 meters in 1,000 seconds. Find the speed of the snail in meters per second. Okay, we have done this already. It's very simple. You can do it in. You can find it in normal form and in scientific notation. Because here you are going to have the speed is distance over time. So you are going to have n divided by 1,000. So you are going to have, I think, 0,01, 0,01. Yes, one delay. One delay, your hand is up.
Sir, I can't say anything, okay? Sir, I can't say anything.
Okay, then let me see here. Let me see here.
No.
You can't see here. Oh. Okay, wait. Let me use the circle.
No, sir,
Let me
I
see
can't
here.
say anything.
Wait. Let me see here. Let me see here. Let me see the circle. Tell me when you see the circle. Just tell me when you see a circle.
No.
You just tell me a circle. Can you scroll your screen and see?
Yes.
It's fine now. It's fine now.
Yeah. I think so.
You can see now. Okay.
Bamba bopi. Wawakazwana nabo namakhona agcwele ngalwa phela. Ethi ufoyele enkani.
Siyosabheka ekhaya.
Hayi man, kathi
Imani Mike siyanizwa.
Hayi.
Ngoba wena uyazi into.
Sicela ngidrop imic siyanizwa la ukuthi
Please, put off your mic if you are not speaking, please. Please put off your mic if you are not speaking.
Angiseklasini la nkini.
Please put off your mic if you are not speaking. Please, I'm freezing. Let me just a minute, please. A minute. I'm freezing. Let me check whether I'm fine. Yeah. Please put off your mic if you are. Please, tomorrow the class will start at 12 o'clock. It will start at 12 o'clock and end at 2 o'clock. Now, only those who are participating for this week. Now, the next one says that write the number of seconds. Okay, no, let's go on to this thing. So, please, here we have there's one delay. Your hand is up again. Speed is distance over time. So we are going to have 0,01. This will be in the normal form. So in scientific notation, the comma will move 1, 2. So it will be 1,0 Please put off your mic -2 if you are not talking. Who are these? Please let me just mute those who are making noise. Into Kozisi. Please put off your mic. I have put him off myself. Okay, good. Times 10 to the power negative 2. Now, yes, one delay, your hand is up again. One delay, your hand is up again. Okay, let's go on. Now, the next one says this, that space rocket takes 2 years to travel from Earth to Mars. Please, there was someone who was asking of this question. If I don't know whether it's the same question. There was somebody who was asking of question 1.1, the last one. Now, it says that a space rocket takes. Dube, your hand is up.
So those people who can mute their mic, they are wasting our time, and we are using our own data here. Can't you just kick them out?
Yes, I've muted them now. I've muted them. Now, let's go on. The next one says that a space rocket takes 2 years to travel from Earth to Mars. A space rocket takes 2 years to travel from Earth to Mars. Given that there are 365 days in a year, calculate the number of hours in 2 years. Yes, Jabulile. Jabulile, your hand is up. Okay. So let's continue. A space rocket takes 2 years to travel from Earth to Mars.
Sorry, sir.
Given that there are, yes, Jabulile, I listen to you.
Yes, sir. Can you please clarify question activity 1.1, number 7 for me?
Okay, no, let's finish with this one, then we'll go back there. You see 1.1, number 7. Okay, good. It says that a space rocket takes 2 years to travel from Earth to Mars. Given that there are 365 days in a year, calculate the number of hours in 2 years. Yes, Jabulele. So there are 365 days in a year. There are 365 days in a year. Have you seen that? But there is 24 hours in a day. So 24 hours in a day times 365. Now it is talking of 2 years. So this will give us the number of hours in a year times, because it's 2 years, times 2. Then if we do the calculation, we are going to get, if we do the calculation, we are going to get 2 times 365 times 2 times 365 times 24 times 24, and our answer is going to be 17520. 17520. So this is in a normal form. So in a scientific notation, we go 1, 2, 3, 4. Then we get 1, 7, 5, 2, 1, 2, 3, 4 times 10 times 10 to the power 4, like that. Okay, now let's go to activity. I think there was something that I needed to show you in activity. You said activity 1,1. Let me see activity 1,1. What is there? Let me see. What is there in activity 1,1? Oh yeah, scientific notations. We are going to look at decimal places. I think we should have looked at this, but I thought okay. Now, please, let's look at decimal places. Please, you have to know that numbers can be written in decimal places. We can have one decimal place, two decimal places. One decimal place is when you have, let's say, 1,2. When we say two decimal places, it's 1,23. If we say three decimal places, it's 1,234. So, in the same way, we can write numbers in ones, tens. You can write numbers in ones, tens, and hundreds. So, for instance, if I give you 5, 6, 4. If I give you 5, 6, 4, this is ones. This is tens. And this is hundreds. Hundreds. So now, if I say write 5, 6, 4 to the nearest 10, it's going to be 5, 6, 0. But if you just change this one to 0, but if the number here is 5 or more, for example, if it's like this, 5, 6, 5, the nearest 10 is going to be 5. You add 1 here, it will be 5, 7, 0. In the same way, if I have a number like this, let's say 1, if I have a number like this, let us say 1, 2, 3, 4. If I say I have a number like 1, 2, 3, 5. If I say write this number in one decimal place, it will be in one decimal place. It's going to be 1, 2. Now in two decimal places, it's going to be 1, 2, 4. Why 1,24? Because the number in front here is more than 5, so I'll add 1 here. But if I say in three decimal places, it will simply be 1, 2, 3, 5. So I hope you get the whole thing. So if the number that they are looking for is more than 5, you add 1 to the previous number. So let's look at this calculation. I should believe all of you can do it because it's a simple calculation with your calculator. Now let us look at number. At least you asked for question 7, but let's look at all the questions. Then we can go to question 7. So the first one says that round off 86425 to the nearest 10. Now the nearest 10 is 4. Have you seen? So you are going to write it's the nearest 10. The nearest 10. You are going to write 8, 5, 6, 4, 2, because the number in front of the nearest 10 is more than 5, it's going to be 5, 0. The nearest 10. Now, the nearest 100. The nearest 100. This is the nearest 100. So it's going to be 8, 5, 6, 4, 2. This time I'm not going to add 1 to the 2 because the 4 is less than 5. It will just be 2, 0, 0. Now, next one says to the nearest 1,000. The nearest 1,000 is going to be it will be 8, 5, 6, but the number in front of the 4 is less than 5. So we can't add 1. So it will be 8, 5, 4, 0, 0, 0, 0, 0. We write it to the nearest 1,000. Now to the nearest 1,000,000. So we have ones, 2, and ones, tens, hundreds, thousands, 10,000, 100,000, 1,000,000. So the number in front of the 1,000,000 is more than 5. So we write 9, and the rest will be 0. 1, 2, 3, 1, 2, 3. Is any questions there? Yes. Yeah. What's first? Then Lowazi.
So you still forgot my question. So in one
Yeah,
point,
you said you said 1 point. I think 1.1 question 6. Ne?
the last question
Okay,
in
so
1.9.
that is the last question in 1.1, which is question 6. Am I correct?
No, question 4.
Question 4 in 1.1.
No, so in activity 1.9, question 4, the second one.
Oh, 1.9. Oh, okay. No, I thought you said 1.1. I'm so sorry. Okay, good. Please, is the explanation clear of decimals? So here too, but tomorrow we are going to talk about this more, so we can look at the question 1.9. Let's see 1. Sorry, I thought you said 1.1. Oz, your question. Oz, your hand is up.
Okay, sir. So it's possible to get 100% from this module, sir.
Yes, yes. I can show you some lot of people who go 100%. I think one time Sabelo, last year, if you know him, one person Sabelo got 100%. Was the highest, I think, both in Bloemfontein and this campus. It's possible, extremely possible. Activity 1.9. Let me see. But it's not that simple. Last year, the reason why he was able to get 100% was because it was only online test. But this year, as we are writing sit-down test, the ball game may not be the same. Yeah. Luazi, you did the first one. So where is what's the problem with the last question? Or what's the last question? Let me see.
So it's just the last question that I had a problem with. The first one in question 4.
Okay, the last one says that the average speed of the space rocket kilometers per hour. Is that the question you are asking?
Yes, exactly, indeed.
Okay, okay, sure. Now, the first one says that, let's read the question again. It says that the space rocket takes 2 years to travel from Earth to Mars. Given that there are 365 days in a year, calculate the number of hours in 2 years. Now, we were able to see that the number of hours in 2 years was 2 times 2 times 365 times 24. Let's start with the first one. Times 24. Then we realized our answer to be 4 times 365. 4 times 365 times 2. Then we got our answer to be, oh sorry, it's 24 here. So sorry. So we got our answer to be 24 times 365 and times 2. Then our answer was 17. The number of hours in 2 years was 17,520. Yeah, I quite remember. Then we converted to scientific notation, 520, sorry. We got 1,752 times 10 to the power 4. Now, the next one is that the average speed of a space rocket in kilometers, the average speed of a space rocket in kilometers per hour, correct to 1 decimal place. So we know that our speed, as we know, is distance over time. So now the question is that what is the distance between F and Mars? If you can look at the question very well, you have been question 1 on activity 1,9. You have been given the distance between F and Mars in kilometers to be 2. You can write in scientific notation that it will be simple. 2 times 10 2,3 to be 2,3. Can you see that?
So no, never mind. I know how to do it now.
Okay,
Because
sure.
I couldn't see the distance, but then since you're using the question 1 for question 4, then I know how to solve it.
Okay, I think it's
All right.
fine. Is any questions again? Please, any questions again? Yes, one delay. Your hand is up again.
Say by average, do we divide our final answer by 2?
Then,
Do we divide our final answer by 2 since they asked for the average speed?
No. Average average can be divided by any number, but here the average speed is simply the speed. I'm saying that the average speed simply means that the speed you have found. When you are driving a car, you cannot go the same speed every time. I'm saying that. So you know the distance that he used, the time that he used. So distance over time will give you the average speed. Average is not always divided by 2. It can be divided by 10, can be divided by 1,000, depending on the number of people you are finding the average of. Does it make sense?
Okay. Yes, thank you.
Yeah. Any questions again? Any questions again? Any questions again? Okay, so
No, say there are no other questions.
there are no other questions.
Yes, sir.
So we have looked at I think we have looked at how to change decimal places and how to find the nearest 10, the nearest 100, and the nearest 1,000 and 1,000,000. Please go and revise that. Tomorrow we are going to hit more on that. So now our next thing that we are going to talk about is at times this topic is challenging, but the first step of we are going to talk about indices, and it is also one thing that becomes problematic for most of you. Please, before you can do indices, you first need to understand the rules clearly. All these rules you see here, you must understand them clearly. Have you seen? And you must understand them clearly before you can be able to do the next one. So please, it is imperative that you understand these rules clearly before you can do the the next thing that we are coming to do. Now, so please look at these rules here, because I can't see how I can explain further, and see whether you have any questions on these properties of indices. Do you have any questions? Yes. Yes. Do you
So
have any questions?
so I have a question on activity 1.14.
Yes, we are going to get there. The first thing
Oh,
is that, do you understand these rules clearly? And all these rules clearly. Yes, Tebile, I have a question.
Yes, on the rules of exponents, in number 4, when it says a over b raised by n is equal to a to the power n over b to the power n. What do they mean when they say b is not equal to 0?
Good. Please, it's very important, because you see that when b becomes 0, this thing becomes meaningless, because you cannot divide a number by 0. Have you seen that?
Yes.
You cannot divide a number by 0. That is why they emphasize. You are going to you cannot divide a number by 0. Have you seen that? That is why I'm saying that.
Okay,
Is
I
it making
understand.
sense?
Yeah, it makes sense.
Good. Okay, good. Now, any questions again? Yes, one delay.
So what if looking at number 4, what if it was a over b to the power negative n? Can that be changed to b over a?
That a over b all the power negative n. Is that what you are saying?
Yes.
Yes, you can. It's the same as b over a, obviously, because it's the reciprocal. All to the power n. Have you seen that? Because when it's negative and it comes up, it becomes positive. When it's negative and it's up, it comes up, becomes positive.
Okay.
Let me see that. Very good. Please, any questions again? Is there any questions again?
No, sir.
Okay, good. Because please, you need to understand these rules clearly. So here it says evaluate the following. You have to know that minus 4 all exponents negative 2 is will be the same as 1 over negative 4 all squared. You have to know that when the power is an even number, even when it's negative, it becomes positive. We've seen that. So we get 1 over 16. Then the next one we have negative 3 all exponents minus 3. It will be the same as 1 over negative 3 exponent positive 3. Because you have to know that when you are finding exponent of a, and the exponent is a odd number, the number is negative, you still have a negative. So we have 1 over negative 20. 1 over negative 27. 1 over negative 27. So the last one we have, please look at the difference here. Here the negative is not in the bracket. See that? The difference between the two. Here the negative is in the bracket. So negative 5, negative 2. Now, because the negative is not in the bracket, when the 5 is coming down, the negative still stays up. It becomes 1. So we have negative 1 over 5 squared. And we have negative 1 over 25. Yes, those. Those. You have a question?
I was saying, will I be correct if I call what you are currently doing inverses?
Yes, they are, yeah, inverse of numbers. Yeah. But you need to look at these simple things, because something as simple as what I'm doing here can make you lose a lot of marks, can make you get everything horribly wrong. So it is important to understand these small tricks, listen, or this small common mistake that you normally do. That costs you a lot. Understand me? That's why we are taking our time to go through this one by one. Have you seen? Because at times it can be that you understand what you are doing, but something as small like this can make everything go horribly wrong. Understand me? Something as simple as this can make everything go horribly wrong. Okay, good. Yes, Oz.
I'm sorry, sir, it's a mistake. I'm sorry.
Okay, good. Now let's go on. So
Sorry, sir.
yes,
I
what's the
want to
question?
ask, yes, on number 3, will I be penalized if I write like this, like that -5 raised by -2? And then if I write like this, 1 over -5 squared, and then 1 over -5.
You see, okay. You see, you write 1 over
Over
negative
-5.
5 squared.
Yes.
Good. If you
And
write
then
here, you have to know
answer.
that because the square and the square doesn't cover a bracket. This
Yes.
2 does not affect the negative. Doesn't mean it only
Yes.
affects the 5. So it's still correct. See that? So you still have negative 1 over
-25.
negative 1 over 25.
Yes.
If you understand it that way. Yeah.
Which means I'm still correct.
Yeah, it's still correct.
Okay.
Because the negative affects all the number, everything there, so it's still the same.
All right.
Yeah. Now, so another rule is that when two indices are multiplying, we add two exponents. Yes, not all of.
Yes, sir. I wanted to ask, what if I do a mistake in the middle of an equation? Do you continue marking or do you just mark the whole sum wrong?
Yeah. You see, it's in two angles here. The first angle is that if the test is an objective test, that one you have to know that nobody will know that you made a mistake somewhere. If the answer is wrong, it's wrong. If it's correct, it's correct. It's as simple as that. So an objective test, we only mark the answer. But obviously, if it's a written test, we mark the steps, not only the answer.
Okay, sir.
Okay, that's how. Okay, so when two numbers are multiplying, it's like 2 exponent 5 times 2 exponent 3. When two digits are multiplying, you add. You are going to get 2 5 plus 3. So here too, you use lot of indices. Please, here you have 2. Let's look at the second one. You have 2 exponent 3 times 3 exponent 2. Here, the laws of indices will not work because the bases are not the same. So here, the laws of exponents is not going to work here. The law of exponents is not going to work here. Now, next one, when is dividing? For instance, if we have 2 exponent 5 divided by 2 exponent 3, we are going to have 2 5 minus 3. You see, we have 2 exponent 2. And because if it's dividing, we subtract. If it's multiplying, we add. But the basis must be the same. So say if we have 2 exponent 3 2 exponent 3 divided by 2 exponent 5. We are going to have 2 exponent 3 minus 5, which is going to give us 2 exponent minus 2. 2 exponent minus 2 is the same as 1 over 2 squared. The same. Then if you understand the rules, it's very easy to simplify this. So we have 4 exponent 2 times 4 exponent 3. Then we have the same as 4, because the bases are the same. 4, 2 plus 3. We have 4 exponent 5. Then here we have 4 exponent 2 all exponent 3. So here, because there's a bracket mean multiplication, so the 2 exponents will multiply. We are going to have 4 2 times 3. 2 times 3. We have 4 exponent 6. Then the next one we have 4 times 3 all exponent 3. Because there is a bracket, this affects every single thing in the bracket. To affect 4 separately, to affect 3 separately. So we are going to have 4 exponent 3 times 3 exponent 3 in that order. Okay, so please go and do activity 1.14. Yes, Luwazi.
When I saw your solutions for activity 1.14, number 3, the answer there doesn't correspond with one of the examples in.
The answer should be 3 exponent 2 times 4 exponent 2.
Yes, so that was the answer, but then you had said it's 12 to the power of 2.
Where? Let me
in
see.
your solutions.
Yes, Luwazi, that one too is not wrong. You understand me? If you write 12, you multiply the bracket first, or because there is something. Did we do board mass? We didn't do the board mass.
Yes, so but then in this example, they're not looking for that specifically.
Okay. Actually, next time that we meet, I thought both of you have done it already, but tomorrow we will do it in the class. You see, there is this thing, B for brackets, O for power order, D for division, M for multiplication, A for addition, and S for subtraction. I thought you have done this already in the face-to-face, so I didn't really touch on this. So normally, things like this, normally you tackle what is in the bracket first. Have you seen? Or you do what is in the bracket first before you come to the exponent. But here, because we didn't really multiply by the exponent, we didn't say 9 times 16. That's why we can write it this way. Understand me? But this way too is also not wrong. Yes, Luazi.
Are you saying it's not wrong if you say 12 to the power of 2?
No, it's not wrong. By board
So it's the
mass.
same,
Board
so
mass
it's the
is
same
the
as
one in the
saying,
bracket.
so are you saying it's the same as saying 3 to the power of 2 times 4 to the power of 2? There's nothing wrong
Yes,
with
you can check on the
writing that.
calculator and get the same answer.
Okay.
You can check on the calculator, the answer. What is not wrong? So you see, in an objective test, you must see that the two are the same. So whichever way they write it, then you know how to put your answer. But it's not wrong. Exactly. Okay, good. The next time we meet, maybe we are also going to look at board mass. I didn't do it because I was thinking we are going to do it. So please, if you understand this, the next time we meet, we are going to go to the real thing and also look at past questions. We are going to go to the real exam because this simple thing carries a lot of marks. But most of the time, then we also look at sets. Most of the time, it becomes a challenge for most of you. So the next time we meet, we are going to conclude with this. Then we are going to look at past questions. Then our next meeting, please. I should think the evening. Should we have them as in the evenings or in the afternoons? Would the evenings be fine? The online class. We have our next class on next week, Wednesday evening. By this time, will it be fine?
Yes, sir. It's fine.
Yes, sir. I
It's
also
fine.
agree.
Okay, good. So we will not have them in the afternoon.
Yes,
The evenings will be fine, where most of you will be inside. Doesn't me? Because the afternoons is a little bit rough. So yeah, we are going to have next week. So next week we are going to conclude Unit 1, and also we are going to discuss past questions. So I'm sure next week Wednesday is going to be the, let me see the date. Next week Wednesday is going to be the 7th. So I'm sure by then you will be prepared to write your fastest one. Is that fine?
Yes, sir. It's fine.
Okay, good. So if it's fine, we are going to bring the class, today's class, to an end. Now, this class has been recorded. So I'm going to prepare the recording and I will send you the link. So if you want to rewatch it, you can watch it. So in the absence of that, the class is closed. Mrs. Your hand is up.
Say class test 1 will be based on units 1 only.
Yes, when I say CT1, Unit 1, CT2, Unit 2, CT3, Unit 3. But the sit down test, one will start from Unit 1 to 4, the other one will start from Unit 5 to 8. So, and that is the semester test. Yeah, one delay, your hand is up.
Oh, say answered.
Okay, good. So please, in the absence of no more questions, we bring the today's session. Yes, Hadebe.
Sir.
Hadebe, your
Going to
hand is
write
up.
the
Yeah.
test on campus or?
No,
Are
the
we going to
online
write the
test
test on campus or online?
is an online test, so you can write it anywhere you have a good
All right.
network and a device. But the sit down, the semester test, you
All
are going
right,
to write
sir.
it at
Thanks.
Mandela Hall. About the sit down
Sir.
test, semester test, it will be at Mandela Hall. Yeah.
Sir.
Yes.
Do we use calculators when writing this module?
Yes, calculators are allowed.
Okay. Scientific one.
Yes. Not graphing
Okay.
calculators. FX82
Sir?
and those type of calculators they are allowed. All graphing calculators, scientific calculators, FX82ZA, those kind of calculators, they are allowed.
Okay, thanks, sir.
Okay, sure. So, in the absence of no question, the Easter holidays, obviously, you should know from Friday to Monday. In the absence of no questions, we bring today's session to a close. But tomorrow, there will be a face-to-face class on campus. Thank you very much.